You look up at the night sky and see mostly empty blackness between the stars. But here's what'll blow your mind. That empty space isn't empty at all. In fact, if you could somehow weigh all the stuff floating around in what we call the vacuum of space, it would outweigh every single star, planet, and galaxy you can see by about 20 to 1. The universe is absolutely packed with invisible matter and energy that we're only just beginning to understand. And the craziest part, the atoms that make up you, me, and everything we've ever touched represent less than 5% of what's actually out there. Let me start with something concrete you can wrap your head around. Right now, you're sitting in Earth's atmosphere, and every cubic centimetre of air around you contains about 25 billion molecules. That's a 25 followed by 18 zeros worth of tiny particles bouncing around in a space the size of your fingernail. But as you go higher up, the air gets thinner. At about 62 miles above your head, there's so little air that we officially consider it the beginning of outer space. This altitude is called the Kármán line, and it's where Earth's atmosphere transitions into the vacuum of space. Now here's where it gets interesting. Take that same fingernail-sized cube of space, but this time in the vacuum between planets. Instead of 25 billion particles, you'll find maybe one. Just one lonely atom floating in that entire space. That's what we mean when we say space is mostly empty, but mostly empty isn't the same as completely empty, and this is where our intuition about space starts to break down completely. Think of space like an enormous three-dimensional ocean, but instead of water, this ocean is filled with incredibly thin wisps of gas, invisible fields, and radiation streaming in every direction. Let me walk you through what's actually floating around out there. First, there's what astronomers call the interstellar medium. This is basically cosmic fog made mostly of hydrogen and helium atoms, scattered throughout space. Hydrogen is the simplest possible atom, just one proton with one electron orbiting around it. And it turns out the universe is absolutely stuffed with the stuff. Between the stars in our galaxy, you'll find roughly one hydrogen atom per cubic centimetre on average. That might not sound like much, but when you're talking about the vast distances between stars, it adds up to an enormous amount of matter. Mixed in with all that hydrogen, you'll find cosmic dust. These aren't dust bunnies like you'd find under your bed. We're talking about tiny grains of carbon, silicon, and other elements, each one smaller than the particles in cigarette smoke. These dust grains form when massive stars explode, when smaller stars shed their outer layers, and through other cosmic processes that scatter heavy elements throughout space. Over billions of years, this dust can clump together to eventually form new stars and planets. Then there's radiation. Space is absolutely flooded with it. Some of this radiation is light from stars, traveling for millions or billions of years before reaching our telescopes. But there's also something called cosmic microwave background radiation, which is essentially the afterglow of the Big Bang itself. This ancient radiation fills every cubic centimetre of space in the universe, carrying the faint echo of creation from 13.8 billion years ago. You'll also find magnetic fields threading through space like invisible highways. These fields are generated by stars, planets, and other cosmic objects, and they guide the motion of charged particles across vast distances. Think of them like cosmic conveyor belts, channeling energy and matter throughout the galaxy. But here's where the story takes a truly mind-bending turn. Everything I've just described, all the hydrogen and helium and dust and radiation, represents less than 5% of what's actually in space. The other 95% is made of two mysterious substances that we can barely detect and don't understand at all. The first mystery substance is called dark matter, and it makes up about 27% of everything in the universe. We call it dark because it doesn't emit, absorb, or reflect light. It's completely invisible to our telescopes, so how do we even know it exists? Here's the thing, when astronomers look at galaxies spinning in space, they're rotating way too fast. According to the laws of physics, galaxies should fly apart from their own rotation, like a spinning top that's going too fast. But they don't. Something with enormous gravitational pull is holding them together. That something is dark matter. Imagine you're watching an invisible person throw a baseball. You can't see the person, but you can see the ball's path through the air, and from that, you can figure out where the invisible thrower must be standing. That's essentially what astronomers are doing with dark matter. They can see its gravitational effects on visible matter, even though they can't see dark matter itself. But dark matter is just the beginning of our cosmic ignorance. The biggest component of space is something even more mysterious: dark energy. This makes up about 68% of the entire universe, and we have almost no idea what it is. What we do know is that dark energy is causing the expansion of the universe to accelerate. Think about throwing a ball up in the air. You'd expect gravity to slow it down as it rises, right? But imagine if instead the ball kept speeding up as it got higher. That's essentially what's happening to the universe. Instead of the expansion slowing down due to gravity, it's actually speeding up. Something is pushing space itself apart, and we call that something dark energy. This creates a truly bizarre picture of what space is made of. The vast majority of the universe consists of substances we can't see, can't touch, and barely understand. It's like discovering that your house is 95% filled with invisible roommates you never knew existed. And there's another layer of complexity here. Space itself isn't just a container holding all this stuff. According to Einstein's theory of relativity, space is actually a flexible fabric that can bend and stretch. When you have a massive object like a star or planet, it warps the fabric of space around it, kind of like how a bowling ball creates a dip when you place it on a stretched rubber sheet. This warping of space is what we experience as gravity. When you fall toward Earth, you're not being pulled by some mysterious force. You're actually following the curved path that Earth's mass has created in the fabric of space itself. This means space isn't just filled with matter and energy, it's also a dynamic, changing medium that responds to everything inside it. Now you might be thinking, this is all fascinating, but why should I care about dark matter and cosmic dust and the fabric of space? Here's why this matters to you personally. First, understanding what space is made of is crucial for our future as a species. If we're ever going to travel to other stars or establish colonies beyond Earth, we need to understand the environment we'll be traveling through. That sparse hydrogen gas I mentioned earlier, it becomes a serious problem when you're trying to travel at a significant fraction of the speed of light. Those single atoms become like bullets hitting your spacecraft. The radiation in space is another major concern. Without Earth's atmosphere and magnetic field to protect us, astronauts are constantly bombarded by cosmic rays that can damage their DNA and increase their cancer risk. Understanding the radiation environment in space is essential for planning long-duration missions to Mars and beyond. But there's a more immediate way this affects your daily life. The GPS system you use to navigate depends on satellites that experience time slightly differently than we do on Earth's surface. This happens because those satellites are in a weaker gravitational field, where the fabric of space is less curved. If we didn't account for these effects that arise from the nature of space itself, your GPS would be off by several miles. And here's something that might surprise you. Every element in your body except hydrogen was forged inside a star and scattered into space when that star died. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar furnaces and mixed into the cosmic medium before eventually becoming part of Earth, and ultimately you. You are literally made of processed space dust. Looking forward, our growing understanding of dark matter and dark energy could revolutionize technology in ways we can't even imagine yet. If we ever figure out how to manipulate dark energy, we might be able to control the expansion of space itself. If we learn to detect and interact with dark matter, it could open up entirely new forms of energy and propulsion. So, what is space made of? It's a complex mixture of sparse matter, invisible fields, ancient radiation, and mysterious substances we're only beginning to understand. Far from being empty, space is a dynamic, ever-changing medium filled with the raw materials of creation itself. The hydrogen atoms drifting between stars will someday become new suns and planets. The cosmic dust carries the heavy elements needed for life. The dark matter provides the gravitational scaffolding that holds galaxies together, and the dark energy shapes the ultimate fate of our entire universe. When you look up at the night sky, you're not seeing emptiness. You're seeing the rich, invisible ocean from which everything, including you, emerged. Space isn't just the stage where the cosmic drama unfolds. It's an active participant in the story, and we're only just learning to read the script.